so let's review some key ideas, all right, regarding kinematics, okay? Now, the first thing, basic kinematics is when you're working with problems that deal with displacement, velocity, and acceleration, okay? Now, displacement, so the first thing you need to remember is if you take the derivative of displacement, so if you take the derivative of displacement, it's going to give you the velocity, okay? If you take the derivative of velocity, it's going to give you the acceleration, right? It's going to give you acceleration. Now, going in reverse, if we integrate acceleration, right, it's going to give us, all right, velocity. The same way, if we integrate velocity, it's going to give us, all right, the displacement. Okay, so whenever you're working with kinematics problem, just when you're reading the question, you have to think, do I need to integrate to get what I want, or do I need to take the derivative to get what I want, right? So depending on what you're working with, and depending on what answer you're trying to find, right, that will determine whether you need to integrate or if you need to find the derivative, okay? All right, now another really important thing is when you're working with kinematics problems, you need to make sure you pay attention to, are you working with the displacement function or are you working with the velocity function, okay? Because let's say you have the graph of displacement or the graph of velocity, right? Depending on what the question is asking, you're going to be looking for different things on the graph, okay? So let me explain what I mean by that. So here's, all right, an example of a displacement graph. Here's an example of a velocity graph. Now you notice both of these graphs look exactly the same, right? It's just that the graph on the right is velocity, it represents velocity, and the graph on the left represents displacement, okay? Now let's say the question is asking, find the smallest value of t, right, for which the particle is at rest. So the particle is at rest when velocity, right, is equal to 0, okay? So on the graph on the left here, this represents displacement, okay? So when velocity equals 0, so remember velocity is the derivative of the displacement, right? So that means if you think about the tangent lines, right? So basically if this is the displacement graph, where will the tangent lines equal 0? Well, they're going to equal 0 here, here, and here. So these are the three spots where velocity is going to equal 0. So the question is find the smallest value of t for which the particle is at rest. So basically the first time that the velocity is going to equal 0, which would be at this point right here. So it would be at 2, right? So if you are working with this displacement graph, all right, and you're asked this question right here, you have to understand that, oh, velocity is equal to 0 at the maximums and the minimums, right, if I'm working with a displacement graph. Now, if you're looking at a velocity graph, this graph already represents velocity, right? That's why it's the velocity graph, right? So this graph represents velocity. So basically, all you're thinking is, if you're asked this question here, find the smallest value of t when the particle is at rest. So the particle is at rest when velocity equals 0. This is the velocity graph. Where's the first time it equals 0? The first time it equals 0 is right there, all right? So your answer, all right, for this question would be whatever that x value is right there, okay? So you notice with this same question, right, we're looking at different, all right, spots on the graph, right, depending on if you're working with displacement or if you're working with velocity. So that's very important when you're working with these kinematics problems, especially when there's a graph involved, right? You have to understand when I have a displacement graph, right, this is what I look for, all right, depending on the question. When I have a velocity graph, this is what I look for, depending on what I have, what the question is, okay? So you notice that same question, all right, is actually even the same graph. It's just that one represents displacement, one represents velocity, but the graph on the left, to find this answer, I'm looking at the maximums and the minimums. The graph on the right, to find this answer, I'm looking for the x-intercepts. Okay? Okay, let's take a look at this second question here as well. Find the value of t when the particle A first changes direction. So first of all, the particle changes direction, right? So it changes direction when velocity, right, goes from positive to negative or negative to positive. All right, so first you need to know that. Now, if you're looking at a displacement graph, remember if you're thinking velocity, right? Velocity is the derivative of displacement. So we're thinking tangent lines. So when does the tangent line go from positive to negative or negative to positive? That's going to be at these maximums and minimums, right? So the question is find the value of t when particle A first changes direction. So it's going to first change direction, right? So right here, right, just think of the tangent line. The tangent line is positive, the tangent line is 0, then the tangent line is negative, right? So it first changes direction here at t is equal to 2, right? But for this velocity graph, right, remember this graph represents velocity already. So when does velocity first change direction? So velocity is negative, 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 and then right here it goes from, right, negative to positive, right? And then it would also change direction again over here from positive to negative, right? So you notice on the graph on the left, all right, the displacement graph, velocity changes, right? The particle changes direction, right? When velocity changes, which is going to be at the maximums and the minimums. But on the graph on the right, if this is the velocity graph, right, it changes at the x-intercepts, okay? So it's very important to understand which graph you're working with, displacement or velocity, and depending on the question, what am I supposed to look for on the graph? Sometimes I'm looking for maximums and minimums, sometimes I'm looking for x-intercepts, all right, and so on. All right, so let's actually take a look at this example here. So first of all, this is a calculator problem, right? So you can use the GDC. So you want to make sure you read this information here very carefully so that you understand, am I working with displacement or velocity, and what is the function that they're giving me, okay? And also make sure you pay attention to the domain of the problem, right? So our answers for t should always be between 0 and 6.8 inclusive, all right? So always pay attention to the domain of the problem, okay? So this first question asks, find the particle's initial displacement from the point P, all right? So the initial displacement is when the time is equal to 0, okay? So when the time is equal to 0. So what you want to do is you want to graph, or for me, I mean, some people like to just plug in 0, all right, for t and then just work it out. That's perfectly fine. But most of the time, you're going to have to graph this later anyways to answer the other questions. So I'll usually just graph this and get the value from the table, right? So for me, on the Inspire, I would graph this function right here, and then I would use the table to get the solution. All right, so after I graph the function, I go to Control T on the Inspire. I get this table. I just go when the x is equal to 0. So then I get 6. So I know that for this problem here, so when s of 0, when the t is 0, I'm going to get 6. Okay? So typically when it's a calculator problem, it's very important for you to kind of show what you're doing. So I would basically tell the examiner that, you know, I graph the function, so I graph s of t right here, and then I just look at the table, right, when t is equal to 0, and then that's how I get my answer here. S of 0 is equal to 6. Okay, so that way, let's say this happens to be 2 marks, right? So basically you're showing you have the understanding of the correct method. So let's say you happen to press a wrong button on the calculator or something and you don't have the correct answer, they'll at least know what you did and they could give you the method mark, okay? So always remember, any paper 2 question, whatever you do on the calculator, right, explain and show to the examiner what you're doing so that you can earn the method mark. All right, if you graphed it and found the x-intercept, sketch like a little graph or something. Okay, so let's take a look at the next question. Okay, part B. Find the particle's velocity when t equals 2. Okay, now if you have the displacement and you want to find velocity, we know we need to take the derivative of displacement, right? And that's going to give us velocity, right? So basically we need to find the derivative of displacement when t equals 2, and then that will give us our answer. Okay, so basically what you're doing here is in the inspire, you're just going to find the derivative, right, of this function when your x value is 2. Okay, all right, so right here I have my TI inspire. So I'm going to go to menu, calculus. I'm finding the derivative at a point. So I'll find the derivative when the value is going to be 2. So your value is 2. This is going to be the first derivative. And then we just type in our function right here. We have 3 times, and then put parentheses. All right, x plus 2 to the exponent cosine x. So cosine x. Now make sure whenever you guys are in calculus, right, that your calculator is in radian mode, because anytime you're working with any functions with sine, cos, tan, you have to make sure that your calculator is in radian mode or you're going to get wrong answers. Okay, so go ahead and just click enter. All right, so our answer is negative 2.2999. So if we round to 3 significant figures, we're going to end up with negative 2.3. Okay, so negative 2.3. So we have negative 2.3. Now make sure your units, right, are correct for kinematics. So anytime, right, this represents velocity right here, right? So the units for velocity in this case here is going to be meters, right, per second. So per second. Okay. So displacement, the units are just meters or centimeters, whatever they tell you in the problem. If it's a velocity, we have meters or centimeters per second, right? So this is how you would write that. Okay. Now let's take a look at the next question. All right, so in part C here, they're asking us, determine the intervals of time, right, when the particle is moving away from the point P. All right, so moving away from the point P. So remember, this represents the displacement graph, okay? So basically what this means is, all right, moving away from point P would be from here to here, right? When it's going down, it's getting closer, all right, it's getting closer to P, right, when it's decreasing. So when it's going up again, it's going up from here to here, right? So basically when it's increasing, it's going away from P. When it's decreasing, it's going towards P, okay? So basically when we graph this on our inspire, right, so on the inspire, if we graph this function, if I'm going to graph, all right, make sure I'm in radian, I'm graphing 3 times parentheses x plus 2 exponent cosine x. All right, so make sure you learn how to play with your zoom a little bit. So let's get this, all right, looking appropriate, right? So I would go to the zoom box afterwards. So typically we want to see this right here, right? So we want to get it to look similar to what they give us in the problem, right? So here's our function. I'll put it up here, it's fine. So we need to find these maximums and minimums. So this maximum here, I'm going to need those coordinates, right? The minimum, I'm going to need the minimum right here. And then it looks like I'll find this maximum over here as well. So basically, all right, from 0 to 0.433, it's increasing. And it's also increasing from 3.255 to 6.33. All right. So that would be your solution. All right, so let me crop this just so I can draw on it. So right here, once I graph this, so it's going away from P, all right, from there to there, and from here to here. So the intervals of time where that's happening is, so basically from 0, all right, to 0, 0 t to 0.433, all right, and from 3.2557, all right, to 6.3396. All right, so these are the intervals of time when the particle is moving away from, all right, the point P. All right, so let's take a look at the next part. All right, so let's take a look at this question here. So it says the acceleration of the particle is 0 when t equals b and t equals c, where b is less than c. Find the values of b and c. All right, so first of all, you have to understand the acceleration, right? Since we're working with displacement, right, acceleration is the second derivative of, right, the displacement. Or you could think of it as, well, acceleration we know is the derivative, the first derivative, right, of velocity. That would give you acceleration. Okay, now since this graph represents displacement, what I could do is I can graph the derivative of displacement, and that'll give me the velocity graph. So that's what I'm going to do. So on my Inspire, so if you want to graph the derivative, so basically all you have to do is you're going to, if you have the d over dx, just have that first, and then type in the function. So when this graphs, it's going to graph the derivative of this, not actually this graph. Okay, so once I've done that, this is what I get right here. So this graph right here represents the derivative of displacement, which means this is the velocity graph. Okay, so since this is the velocity graph, let me just screenshot this real quick. So this is our velocity graph, right? Now we want to know when acceleration, right, of the particle is 0. So when acceleration is 0. So acceleration is the derivative of velocity. So meaning the derivative of velocity, right, is when the slope of the tangent line on the velocity graph is 0. So the slope of the tangent line on the velocity graph is 0 here and here. So that means that our b value would be approximately 1.2314, and our c value would be approximately 5.689, right, 5. Okay? All right, so let's take a look at the last part of this question, part E. Find the total distance traveled. All right, so total distance traveled, this formula is actually in the formula book. Right, remember total distance traveled is when we're integrating the absolute value of the velocity function. Okay? So find the total distance traveled by the particle for B, all right, for when the time is between B and C. So B and C, remember we found that earlier. That was our values here, 1.2314 and 5.6895. All right, so 1.2314, so 1.2314, and our C value was 5.6895. All right, so 5.6895. All right, so basically we need to integrate. So the idea is we are going to integrate, right? So we're integrating, all right, from 1.2314 to 5.6895. Now we're doing the absolute value of velocity. Now here's the tricky part. We don't have the velocity function. We have the, right, displacement function. But remember, if you take the derivative, right, of displacement, that's going to equal velocity. So when you do this on the calculator, what you have to do is you have to make sure you take the derivative of this so that what goes inside here, right, is velocity. Okay, so let me show you how to do that on the Inspire. So let's go to calculate, make sure we're in radian, we're going to integrate, right, from, all right, we had 1 point, what are the values? 1.2314, right, 1.2314 to 5.6895. Now in here, you want to absolute value this, right? So click the button right next to the 9. All right, the absolute value is right here. So now, remember inside here, we need the velocity function. So velocity is the derivative of displacement. So we need to take the derivative of this function. So we need to have that d over dx first. So you're going to click this. So we have the d over dx. This means if I take the derivative of displacement here, that will give me velocity inside here. So I'll get 3 times parentheses x plus 2 to the cosine x power, cosine x. Double check, make sure everything looks good. Looks like everything is good. All right, and we're integrating with respect to x. All right, looks like everything is good. All right, so you notice inside here, you have to put d over dx, right? Because this means the derivative of displacement, which is velocity, all right? So inside here must be velocity because our formula for total distance traveled, all right, is the absolute value of velocity, right? So if you don't put the d over dx here, your answer is going to be wrong because you're just integrating displacement, okay? So go ahead and click enter. We get our solution, 9.55, or 19.55, which is 19.6, okay? So let's say we get 19.6. I can screenshot this just so we have it right here. So we get 19.6. So our answer is going to be 19.6, right? And then distance traveled, so it is in meters, okay?